Welcome to the second lecture of module 2 in the subject hydrology and water resources. So today we will be talking about rainfall and index of wetness and rain gauges and type of rain gauges and network of rain gauges, which is the network we establish to record the rainfall data. So in the last class we were talking about types of rainfall. That what are the types of rainfall? Frontal precipitation, then convective precipitation, cyclonic precipitation, and orographic precipitation. So these are the types of precipitation, and in India the most common type of precipitation is rainfall. So once we know that rainfall is very important for Indian perspective, so we must be talking about rainfall in a detailed manner. So here we are talking about rainfall. So there are 2-3 terms related to rainfall. So what are the terms? So the first term is daily rainfall. So what is daily rainfall? It as name suggests, daily rainfall. So it is basically the amount of rainfall which happens for one day. Okay, so this value of rainfall is called daily rainfall. Second one is annual rainfall. So let us say that if one day there is rainfall is there, and suppose its value is 1 unit, or let's say it is 1 unit, so its daily rainfall is 1 unit. And if every day there is all the 365 days in a year, the same value of rainfall precipitates, then for whole duration of your year, the amount of rainfall will be 365 units. So what is annual rainfall? It is a rainfall for 1 year or one complete year. Whatever value of rainfall precipitates for a duration of 1 year, then that summation of rainfall for whole 1 year will be called annual rainfall. Okay, and the third term is average annual rainfall. Okay, so what is average annual rainfall? So let's say that there is a condition that in first year, in 1 year, or in the first year, suppose let us say rainfall is 110 centimeter. In the second year, rainfall is 120 centimeter. In the third year, rainfall is 109 centimeter. Okay, so these are the values for one complete year. Let us say this is some 2000, and this is for the year 2001. This is for the year 2002. Likewise, if you will check values for 2035, okay, sorry, 34. Let us say this is some 120 degrees. So these are the value of rainfall for 35 years. What are these values? They are these values. Annual rainfall. So if you have annual rainfall for a long duration of time, here I have mentioned that 35 years. So if you have values of rainfall for 35 years and you average them and calculate one value, then it will be called as average annual rainfall. Okay, so is it important to calculate this average annual rainfall? Yes, it is very important, because let's say if you are in one place, let us say you are in Chhapra right now, and there is another city, let's say New Delhi. So if I will ask among these two cities, Chhapra and New Delhi, which city receives more rainfall? So how will you answer this question? Okay, so what will you do? You may check rainfall for this particular area, this particular year, and then you can say that this year the rainfall is this much, and for this year rainfall is this much. So based on this you can answer, but this type of answer is not correct. Okay, because you are talking for one particular year, but the question I am asking that which city receives more rainfall, whether it is Chhapra or it is New Delhi. So you cannot answer based on one particular time or one particular year. So you have to answer you have to give answer based on a long duration of time. So in such cases, this parameter average annual rainfall becomes important. So now how should you answer this particular question correctly? You should calculate average annual rainfall for Chhapra city and same value for New Delhi city. Whichever value is greater, so that city will receive more rainfall as compared to either. Okay, so this is how you should answer. So that is why this average annual rainfall is important. It tells the climate of that particular area. Okay, it tells about the climate of that particular area. Okay, so this is how you should answer. Apart from this, there is a note which says that the average annual rainfall for India is around 120 centimeters. Some books also write it as 119 centimeters. So based on this 35 years, it keeps changing. Okay, so some may give answer around 119, but it is a rough value, a round value. Okay, so India receives around 120 centimeter rainfall every year. Okay, so now if somebody want to ask a question, okay, let me calculate how much value does India receives, okay, in 1 year, how much rainfall India receives, or how much volume of water does India receives. So a person can easily calculate this. Okay, so how you can use this value? Let's say, what is the value of rainfall? 120 centimeter. So if you want to answer this question, what is the volume of water received by India as rainfall? So you can simply calculate this as volume is equal to height multiplied by area. So what height is? This one, 120 centimeter. So it is 120 centimeter. And what is area of India? What is geographical area of India? You can refer to any map, or you can check Google also, and you will find out that the volume of the geographical area of India is around 3.3 mega hectare. Okay, and then you can solve this and you will get the value of volume of water that is received by India for one complete year. Okay, this is a rough value or average value of water. Okay, so if you have this, you have such type of question in your mind, you can answer them very easily. Okay. Similarly, you can also calculate this for state of Bihar, or you can also calculate this for Chhapra city also. Okay. Depending on you just need this value of average annual rainfall and the geographical area. Okay. So this is how you can do it. So let's move forward. So next is the index of wetness. So what is index of wetness? So see here, like now you are in a city and you calculated the average annual rainfall. Okay, and now you have a question in your mind that in this year whether there was sufficient rainfall or not, or it is a good year in which rainfall was fair. Okay, if you have this type of question, how should you answer? So there is a one parameter which can help you, is index of wetness. So what is its value? It is rainfall in a particular area is when divided by average annual rainfall. Okay. So sorry. Okay, so I have done a mistake. It is not year. Okay. So what is the index of wetness? It is rainfall in a particular area which is when divided by the annual average rainfall of a particular location. This is basically location. Okay. So into 100. So this is a fraction multiplied by 100 is a percentage. So this is nothing but percentage. So you calculate a percentage, and this percentage then you can observe here that if this percentage is exactly equal to 100%, okay, कहने का मतलब है जितना आपका एवरेज एनुअल रेनफॉल था उतना ही रेनफॉल एक पर्टिकुलर ईयर में होता है. Okay, let us say in 2020 the amount of rainfall received, okay, is, let us say 110 centimeter. Okay, and the average annual value is also 110. Okay, so it is completely 100% value of index of wetness. So this year will be called as a normal year. Okay, this is a normal year, the rainfall is fair. And if this index of wetness is greater than 100%, then it will be called as good year, good monsoon or good year. Okay. Similarly, if index of wetness is lesser, then we will say that this is a bad year, and this year there was insufficient rainfall. Okay, so this is the way you can identify the particular area or how was the rainfall. Okay, so let's move ahead. Okay, so now you know that what are the types of rainfall, and you know how to term the rainfall, like daily rainfall, average rainfall, or annual rainfall, average annual rainfalls. Okay, you have termed them, and now you want to measure the value of rainfall. That how you are going to measure the rainfall. So it is a very simple concept. That let us say some rainfall is going on, and you have kept a small glass or small jar. Okay, some rainfall is collected by this small glass, and the amount of rain volume was collected in this particular glass, and this much was the height. This much was the height of water that was stored in this small glass. Then we will say that, let us say this is height h. Okay. Then we will say h height is the amount of rainfall. Suppose let us say this is 10 centimeter. Okay. Then what will we say? We will say that today the rainfall was 10 centimeter. Okay. आज 10 सेंटीमीटर बारिश हुई. Okay, we are not estimating it in terms of volume, we are estimating it in terms of height. Okay, but now why we are doing this in terms of height? Because let us say that if there is a city and there is some rainfall, then it is impossible to measure all the volume that happened in the whole city. So it is impossible. So you cannot take volume as a characteristic dimension. So you can take this height as its substitute. Okay, and height will be more significant term to represent the rainfall. So this is how you can measure the rainfall. But the problem is now if you change this glass, okay, if you change this glass, or if you will put a glass like this or something like this, then this height will change. So there's a problem now that you cannot keep any glass in the rain, and you cannot say that this is the amount of rainfall which happened today. Okay, this is the issue with us. So what should be done? So what we have done, we have fixed this area. Okay, we have fixed this area. We have said that we have given a standard value, that this is a standard value. If I have to measure rainfall, I should keep this area as this one, and then I will measure the height. Now everybody who have this thing, okay, who have this kind of class, they can convert the volume in terms of a particular standard, and all the people will report the same value because of this standardization. Okay, so this is how you have to measure the rainfall. Okay, so let's move ahead. So here I have also mentioned that the device which is used to measure the rainfall is called rain gauge. Okay, so rain gauge is basically based on this concept only. Okay, so let's jump to rain gauges. So rain gauges are based on the same concept that we discussed earlier, that some area is fixed and then height is measured, and the measured height will be called the height of rainfall or the amount of rainfall. So this much is talking about the same thing only. Also sometimes pluviometer, ombrometer and hydrometer are also referred as rain gauges only. They are the other name of rain gauges. Okay, and once you know rain gauge, now there are two types of rain gauges. The first type is called non-recording rain gauges, and other is called recording rain gauges or recording gauges. So what are they? Let's talk about them. So first we will talk about non-recording rain gauges. So what are non-recording rain gauges? So this is one picture of this Simon's gauge, which is one of the non-recording rain gauges. So what is it? So you can find the same concept here. Here one flask is there. Okay, one flask is there, and there is a small funnel is there. Okay, so when rainfall happens and it gets collected in this funnel, and which gets collected ultimately in this jar. Okay, and this height of water, we say that this is the amount of rainfall today. So it is an example of Simon's gauge. So what is happening here, that if we want to read this height, okay, one person have to go to this particular rain gauge and should read it, okay, and then only he can answer this thing. So there is no automatic system which can record this value. So that is why they are called non-recording rain gauges. A person is required to read this value. The gauge is not automated to read and record this value by himself. So a person is required. That is what they are called non-recording gauges. So since in the very beginning, when this type of rain gauges were established, so there was a person which were appointed by the department, let us say IMD, in Indian Meteorological Department. So there was a person whose job was to go to rain gauge and should read this value. Okay, this was a job of a person. Now when this happened, there was a problem that it may happen that person record the value of rainfall at 9 o'clock, and some other person may read this value at 10 o'clock, some at 11, some at 12. So there was an issue that even though everything was set up, but answer reported by every person was different. So a standard was made that we will not read the height in this manner. Rather, what we will do, we will fix the time. Okay, so that is why you can find the book, and this is that at 8:30 a.m. Indian Standard Time, a person records the daily value of rainfall. Then only you can say that it is the acceptable value of daily rainfall. Okay, if you record it some other time, it might not be justified or might not be acceptable. So this is how it happens in India. So this is a basic example of Simon gauge. Simon gauge is one of the non-recording gauges. So there can be a number of non-recording gauges. You can explore them. There are 100 of such gauges. Let's move forward and let's jump to recording gauges. So what were non-recording gauges? Non-recording gauges were which were not able to record the value of rainfall by himself or by itself. There was a person was required to read the value. Okay, so this was the issue with non-recording gauges. So this problem was removed by the help of recording gauges. So there can be a number of recording rain gauges. One of the example is tipping bucket type rain gauge. So what is it? So this is a picture of tipping bucket type recording gauge. So what happens in this? You can see it from here. So when rainfall happens, it is collected in this one. Okay, and then it comes like this, and it got recorded in this small bucket. And once this bucket gets filled, the water starts reaching this point, and this thing gets tipped. Okay, this thing gets tipped like this. It gets tipped like this, and all the water goes down, and this side goes in this portion, and then water starts filling in this one. Okay, now here we attach one sensor which records the number of tipping, that how many times this bucket gets tipped. So we keep on counting this number of tips, or number of time the bucket slided. Suppose it slided 5 times, and one bucket can be filled for 5 centimeter. So for 5 centimeter and 5 times tipping, there is total 25 centimeter of rainfall. So this type of gauge can record by himself. So if you are thinking of startup, then you can use similar type of easy concept for developing your own rain gauges. Okay, you just have to stick to the Indian standard code, and you can also make such type of instrument very easily. No concept is required. You just need to fix 2-3 sensors and the automation of the gauge. So this is one kind of rain gauge. There can be several type of similar rain gauges. So some of other type can be this natural siphon, weighing bucket, telemetry rain gauges. There are similar example of recording gauges which can record the value of rainfall by themselves. Thus, it is only a addition of some automation in the rain gauge, but the basic concept is the same. You have to collect the volume, you have to divide by area, and the height will give the value of rainfall. So this is how rain gauges are classified. Let's move forward. Now you know that what are the types of rain gauges, okay, how they are classified. Now if you work in a department which keeps record of rainfall data, then you have to establish rain gauges in various parts of the country. Okay, if you will not establish rain gauges in various parts of the country, you will not be able to record the value of rainfall. Okay, so for this, the Indian Meteorological Department always establishes the rain gauges in various parts of the country, and this all the rain gauges collectively are called the network of rain gauges. Okay, so which is called rain gauge network. Now the question is, how many rain gauges should I establish? Okay, so to answer this one, they have given some of the guidelines which you should remember if you are thinking to appear in engineering services or any public service examination. These values should be remembered. So if the area is flat, then for every 600 to 900 square kilometer area, there should be at least one rain gauge. Okay, this is the ideal condition. But if you cannot satisfy this condition, there is bare minimum requirement, which is this one, 900 to 3000 kilometers square. Okay, so two types of limits were given. One is ideal. If you are very rich department, you should go to this. If you are not able to maintain this much, you should at least maintain this one. Okay. Similarly, if you are talking about mountainous region, then ideal condition is around 100 to 50 kilometers square for one rain gauge, and the acceptable is 250 to 1000 kilometers square for one rain gauge. Similarly, if the arid region is there and we are talking about the polar zones, then for every 1500 to 10,000 kilometers square, there should be at least one rain gauge station. Okay, so let us say you are a department or you are meteorological department and you have established all the rain gauges in in the whole country or in a particular area. Then there is another guidelines that total number of whatever be the total number of rain gauge that you establish, out of which 10% of the rain gauges should be recording type rain gauges. जितने भी आपने रेन गेजेस स्टेशन लगाए हैं उसमें से कम 10% रिकॉर्डिंग टाइप रेन गेज स्टेशन होने चाहिए. दिस इज ऑल्सो वन ऑफ द गाइडलाइन ऑफ इंडियन मेट्रोलॉजिकल डिपार्टमेंट. ओके, सो दिस इज ऑल अबाउट today's class. I hope this is helpful. Thank you very much and we'll meet in the next segment. Thank you.